Hello, everyone, and welcome to Cisco Unplugged. My name is Dan Clamert, leader of the Wireless Center of Excellence here at Cisco. This week in episode 21, we're going to be discussing 6 gigahertz and automated frequency coordination, or AFC. And I am honored to welcome back to the show Francis Gerard from Montreal, Canada. How are you doing, Francis?
Doing great. Really happy to be part of this show on AFC. Hot topic for sure.
Yeah, definitely looking forward to it. And we also have a special guest here today, Anand Gurumurthy. He's a TME leader from San Jose, California, and the business entity. Welcome, Anand. How are you doing?
I'm doing great as well. And I really thank Francis and the extended Unplugged team, Ian, Tom, and others, for inviting me to today's episode of Unplugged. And my hello to all the viewers who have tuned into this, session.
Yeah, thanks. Looking forward to it. Before we get rolling here, just a couple of reminders. This session is being recorded, and we also have people answering questions via Slido. If you've joined, you can submit your questions via WebEx, or if you are watching via YouTube, you can also submit your questions there via Slido. Both ways, we have people monitoring those questions via Slido, and we'll also maybe take a couple of those questions live if we have time. Also, just another reminder, like I said, this is being recorded as usual, and you can find this and a lot of other great content out on our Unplugged channel at youtube.com/@getunplugged. You can also see upcoming episodes and what we have scheduled on the docket. We've got some great content planned for the new year. We also have one episode remaining yet this year. We're really excited about that one as well on December 13th. So you can subscribe and get those on your calendar at cs.co/getunplugged. Also, speaking of subscribing, go to our YouTube channel, subscribe there, and you'll be notified when we do post or go live with new content. All right. Thank you. And that's it. Now on with the show. Francis, take it away.
All right. Thanks, Dan. I'm really excited to have Anand doing this show. I mean, over the last year, two questions I get very frequently. And the first one being, how come I can't have APs doing 6 gigahertz outdoor and, or APs with external antennas? That's the first question. And I explain, well, you need AFC in place and so forth. And then the next question for sure is, okay, when were you going to get all this? And I know that, Anand, you're going to be answering all of this and more over the next 30, 40 minutes or so. So I'm really excited about this. But before we go on and actually explain what AFC is, how it works and how we implement this in our controllers and the Meraki dashboard, I think it would be a good time to do a bit of a refresher / update on current regulation, not just across North America, but as well across the world. So take it away there, Anand.
Sure. Thanks, Francis. AFC is going to be available pretty soon, and in US, of course. And this is a perfect timing to discuss about the topic. I know it's been a long wait, and a super long wait, I would say. We've been talking about AFC almost close to 2 years since the launch of Wi-Fi 6E. So the wait was due to multiple reasons. The regulations, the development of the AFC, the cloud system, the compliance certifications, and the end-to-end validations, and there were several steps involved in the journey. The good news is the wait is almost over, and I would say we are almost in the final stages of launching this functionality here in the US. And I'll share some more details on the timing later in this session today. By the way, early field trials for this functionality are in full swing in US, and there are multiple customers trying out AFC and standard power in 6 gigahertz. We obtained the experimental licenses for them. The feedback has been great so far, and it's a very good validation from multiple customer sites actually before we launch this functionality. So you asked me to talk about the spectrum regulations, and yes, it'll be a good starting point, and I guess it'll be a good recap as well, and also set the expectation. I mean, context for today's discussion. So first, let's see the latest on the 6 gigahertz adoption for Wi-Fi worldwide. As of now, there are close to 60-odd countries that has adopted the 6 gigahertz spectrum for unlicensed use of Wi-Fi. In short, there are two camps. Camp number one, countries that has authorized the full 1200 megahertz of spectrum, mainly in North and South America, and a couple of countries in Asia, South Korea, and Saudi Arabia. And camp number two, countries that has authorized the 500 megahertz of spectrum, the lower portion of the 6 gigahertz spectrum, in Europe and most countries in Asia. But there are several countries who have adopted the 500 megahertz of spectrum, and they've already started evaluating opening the entire 1200 megahertz of spectrum for Wi-Fi use. So as we speak now, the World Radio Communications Conference is currently underway. It started, I think, November 20th or so, and going to go till mid-December. It's happening in Dubai, and one of the topics of the discussion is to open the entire 1200 megahertz of spectrum. If they happen to reach a conclusion, it will definitely have a huge impact to the Wi-Fi market, and it will open up the next steps, discussions on AFC and standard power in those countries, as well. The spectrum starts at 5925 megahertz and ends at 7125 megahertz for those countries with 1200 megahertz of spectrum. And it ends at 6425 megahertz for countries with 500 megahertz of spectrum. The spectrum is further broken down to Uni 5, 6, 7, and 8 bands. One key thing to note here is that the spectrum is something not unoccupied and fully available for Wi-Fi use. There are incumbents here. Example, the fixed microwave operators, this point-to-point microwave links, the fixed satellite services, the TV operators, the mobile vans who relay the events from remote locations to the TV stations. All these operators are licensed operators, and they pay money to use the spectrum. And this spectrum is now extended for unlicensed use of Wi-Fi. And if the Wi-Fi devices have to coexist with the incumbents, they should not cause, any interference here. So the regulators came up with this nice idea of device classes that actually defines on how and where these Wi-Fi devices can operate without interfering the incumbents. This concept is something new in Wi-Fi. The first in this category is the low power indoor AP. All the access points that we ship today, and in fact, all the access points that's available in the market, they all operate in the low power mode. The rules here are these APs can operate only in indoor, and they have to have an integrated antenna. They cannot have an external antenna. It cannot be used for outdoor purposes. And they are okay to operate the entire 1200 megahertz of spectrum. The second in this category is the standard power. These APs operate at a higher power level, and they can operate in indoor or outdoor environments. And they can also have an integrated or an external antenna. And if you look at this, since these APs operate at a higher power level, and also they can operate outdoor, they have the potential to interfere with the incumbents. And hence, they have to operate under the control of what is known as an automated frequency coordination system, or AFC, which will dictate the channels and the power levels that these APs can operate in standard power mode based on its geolocation. And, so today's session is all about the second category of standard power and AFC, and we're going to deep dive into this more. By the way, all the Wi-Fi 6E indoor APs that we have today can operate in both low power and standard power. And it's just that, it's like two different modes when they operate in the 6 gigahertz. And these modes are configurable. The outdoor AP, the restriction there is it can operate only in the standard power mode, and it cannot be put into a low power mode. So the third category is the very low power APs. The use case here is the personal hotspots and this access points mounted on vehicles. This, of course, is not applicable to the enterprise deployments. They are expected to operate in really very low power levels. And since they're going to operate in a very low power level, they don't have the potential to interfere with the incumbents. And hence, they are okay to operate both in indoor as well as in outdoor. And they're also free to operate the entire 1200 megahertz of spectrum. The final in the device category is, of course, the clients. There are again subclasses here, which we'll see in a bit. The clients must operate 6 dB lower than the AP power level. Of course, these regulations vary by country. The example that I took here is for FCC and ISID. And as of now, there are only 2 countries in the world, US and Canada, who has approved the use of standard power mode in 6 gigahertz under the control of AFC. US is slightly ahead in the game and is very close to give the final go-ahead. Canada is expected to go operation sometime in the next calendar year. And no other country has defined the AFC system yet. Though some countries are in early stages of discussion. And Cisco is very much involved in discussions with most regulators around the world, So as of now, only indoor AP with an integrated antenna is permitted in the rest of the world. So there is a small difference in standard power mode operations in US and Canada. Advantage Canada. In US, the standard power mode is permitted to operate only in the Uni 5 and 7 bands. Whereas in Canada, the regulations permit the standard power mode operations in Uni 5, 6, 7, and 8 bands, which adds like another 100 megahertz of additional spectrum for standard power mode. So moving on to the power levels, the standard power mode can go up to a 36 dBm of max ERP under the control of AFC. The power level is defined in PSD, or power spectral density, which is the amount of power over a given bandwidth, and is capped at 23 dBm per megahertz. And if you do the math, it results in 36 dBm, which is the max allowed ARP. For low power mode, the PSD is defined at 5 dBm per megahertz, which results in different ARP levels as you bond the channels. For 20 megahertz, the max ERP is 18 dBm, and 40 megahertz, it's 21 dBm, and so on. Whereas in standard power, the max ERP is always 36 dBm, irrespective of the channel width. The clients, of course, have to follow the AP's power level by having 6 dB lower power. So one of the questions that I get asked very often is, what is the benefit of having standard power mode for indoor operations? For outdoor, you don't have a choice. And as per regulations, the AP always has to be in standard power mode and has to operate under the control of AFC. You cannot have an AP in low power mode for outdoor operations. So the regulations clearly dictate how the outdoor APs have to operate. But the question is, why would one want to go with the standard power mode for indoor? The benefit is actually twofold. Number one, you get a bigger cell size, longer range, which helps in like high ceiling deployment and even in carpeted office deployments. You can achieve a similar or better coverage when compared to that of a 5 gigahertz cell. If you think about it, due to free space path laws and physics, for a given power level, the cell size of 6 gigahertz will be slightly smaller than 5 gigahertz by about like 2 dB. So with the low power mode, you have to crank up the power level of the 6 gigahertz radio to get a similar coverage of a 5 gigahertz. With standard power, there won't be a need to crank up the power level, assuming the power level returned by AFC is going to be better than the low power mode. Advantage number two is you also get a slightly better throughput when compared to low power. From our test, what we have done in the lab, we see a 10% improvement in throughput at further distances from the AP. The only con that I would say is, of course, you lose 350 megahertz of spectrum, and you lose about like 17, 20 megahertz channels or 40, 80 megahertz channel. The reason being, standard power is permitted to operate only in the Uni 5 and 7 bands in US. So this is where the intelligence of RRM and ARRM come into picture, where they balance the standard power and low power mode APs depending on the floor conditions and optimize the channels and the power levels. There is in our implementation, there is a bias towards SP, but if the situation warrants, an AP would be put in low power mode. So, the RRM will do so to get the best, optimized results.
Super. So question here on standard power. The great explanation is in regards to the device classes and whatnot. Does this require new APs, or can I run standard power on the existing indoor APs? Because you've been talking in the last slide for using standard power indoors.
Absolutely. All the Wi-Fi 6E APs are capable of running in both the mode, the low power and indoor. And today there's a software restriction to run only in the low power mode. And once this AFC is approved, also our access points are certified for standard power operation. It's just a matter of software, So you can operate in short, it can operate in both the standard power mode and low power mode. And also one thing to note that is, so when an AP changes from low power mode to standard power mode, there's not like an AP is going to reboot and come back and join. It's just a matter of a radio reset and gets into the standard power mode operation, and vice versa.
Great. And these APs, like especially the 91, 62, 64, and 66, they can operate with 802.3 AT PoE plus power. With full radio capabilities, client servicing radio capabilities. If I turn standard power on, that means more power to the radios. Do I need to, move on to 802.3 BT UPoE for this?
Absolutely not. And 91, 66, and 64 and 62 is it capable of operating in standard power mode with an AT power, and you don't need a BT power.
Super. That's awesome. Great to know. And it's been a concern to actually get the same coverage in 6 gigahertz with low power indoor than we have on 5 gigahertz. Being able to maybe bump up using standard power to a little bit higher level certainly will address any issues in that regards. Okay, so moving along here, you've talked about the requirement AFC to be able to enable standard power on APs and to use 6 gigahertz outdoors and external antennas and whatnot. And this is basically to protect the incumbent, right? It's not as if the 6 gigahertz band was available for everybody to use whatever they wanted, right? We need to protect those incumbents. We have databases of licenses that were provided to incumbents. So tell us, moving on, with AFC, how does this work? How can our Wi-Fi systems using 6 gigahertz can actually, make sure that we're not interfering with these incumbents?
Sure. So in short, what exactly is an AFC? AFC is a cloud-based operator. Example, Federated Wireless, Google, Qualcomm, and there are actually about total of 13 providers in US who have been given the conditional approval by FCC, and similarly, Canada has approved a few providers as well. They have access to the FCC's or ISD's incumbent database and the geolocation. So when the AP wants to operate in standard power mode, and before it makes its radio operational, it has to provide its geolocation coordinates to AFC and request for channels and power level that it can operate. So in our case, it's the Catalyst 9800 controller, if it's an on-premises deployment, or Meraki dashboard, if it's a cloud-based deployment, that will proxy on behalf of the access point. And they'll present the geolocation and they'll make the query. So the AFC will query its database, do the computation to see if there is any overlap in the geolocation, and respond back with the channels and the power level that the APs can operate. The RRM in the controller, or the auto RF in the case of Meraki, or ARRM in both the cases, will distribute the channels and power levels accordingly. So what the AFC does internally is it computes a heat map or a protection contour around the incumbent's fixed receiver. If the 6E access point is outside the contour, it won't put any restriction. If it's within the contour, and depending on where the AP's geolocation falls in the heat map, there'll be constraints placed. If it's in the red area, then maximum restriction is placed. And as you move away from the red, the area, the constraints are relaxed. Basically, the power spectral density that is returned, it's given more as you move away from the red area. So let's see how AFC solution works in our Cisco's wireless architecture. So in the on-prem deployment, the Catalyst 9800 controller presents the geolocation of the APs. It relays the information to the Cisco Cloud Proxy services, which in turn relays to AFC. In the Meraki deployment, the Meraki Cloud acts as a proxy for these APs. The communication between the controller or Meraki Cloud to the AFC is through like well-defined APIs and through a secure connection. So what is the information that is sent to the AFC? The very, very first step is, of course, the authentication between the proxy and the AFC through like exchange of tokens. And the next step is the request query from the Catalyst controller or the Meraki Cloud with the geolocation of the APs, the latitude, the longitude, the height, and the uncertainty factor in measurements, along with the FCC ID and serial number of the AP. So this query is sent once a day. It is every 24 hours from the very, very first query. So the AFC then responds back with the allowed channels and the power budget, based on its computation for that, geolocation. So what you see here is an output of a sample request query sent to the AFC provider. The data is in JSON format. The query is sent once every 24 hours from the very first query. As I mentioned, the query contains the serial number of the AP, FCC ID, the longitude, the latitude, height at which the AP is mounted from the ground level, and the channel list. By default, the query is made for all the channels. There's an output of sample data on the response received from AFC. It has the channel numbers, the frequency, channel width, and the maximum ERP that the AP can, never exceed.
All right. Super. So the system, be it on-prem, the controller or Meraki dashboard, needs to report this, if I get this right, on a daily basis, every day, 24 hours?
Yes, it has to refresh its, it has to send a query every 24 hours.
And what happens if for some reason the system can't reach, and you mentioned, Cisco proxies this, but so what happens if the system can't reach all the way to the FC to get a response? Does it need to shut down, or what happens there?
So what we do is, even though it's 24 hours, normally we schedule the query slightly before 24 hours, maybe a couple of hours prior to the 24 hours expiry, right? So we start trying it out, ahead, proactively. Let's assume, you don't have an internet connectivity for, a couple of hours, the time has passed and the AFC service is down. Then the controller would revert back all the APs to the low power. We don't operate in the standard power. So, that's our implementation. And that's the way we are supposed to implement. That's as per the specs.
Okay. And so who runs the AFC? You mentioned that Cisco acts as a proxy. So like, do we need to, do we need additional licensing? Do we need to register with the external AFC system for our own use?
Absolutely not. In fact, I'm going to show in the demo. We have made all this very simple. The user need not worry about who the AFC provider is and so on and so forth. There could be multiple AFC providers. And this is completely hidden from the user configuration, and it's all taken care of the backend. And regarding the license, you don't need any additional license. It's just the basic license, both the Catalyst and, on the Meraki side.
Super. Yeah. Okay, so the systems need to report their exact location. You mentioned latitude, longitude, even height, and GPS. Yeah, some of your slides actually showed like a GPS module or antenna attached to the APs. But our APs, the currently shipping APs anyway, don't have GPS capabilities built in. Just a few weeks back, we did recently on Unplugged, we did an episode introducing GPS modules to support various applications such as AP auto placement on maps. Are we leveraging the same modules here?
Absolutely, yes. And let's. So the geolocation information is, along with the height, is a mandatory piece of information that the AFC needs, and without which the AFC is not going to respond. And as per the rules, the latitude and the longitude cannot be manually configured, and must be obtained through an automated way of using GNSS and GPS. So, but it's okay to enter the height manually, though. So what we did was, like, we came up with this GPS module that plugs into the USB ports of the indoor AP to get the precise geolocation. The GPS module consumes very little power, and again, you don't need like a BT power to operate. You may wonder, like, why Catalyst 9130s, which is a Wi-Fi 6 AP, is listed in the supported APs. The GPS module, as you rightly said, finds place in other applications like the AP autolocate feature, which I think was covered in episode 17 of Unplugged, right? So, the AP is slightly far off from being close to window. Then you can use an external GPS antenna along with a cable that plugs into the the GPS module. If you pop open the cover in the GPS module, you can plug in the external antenna cable into the MMCX connector, and you can go up to a maximum of 10 meters and mount the antenna on a window or in a location where it can get a clear sky view. So we recently released the outdoor Wi-Fi 6E AP, the Catalyst 9163E, and that has an inbuilt GPS antenna. It also has a provision to attach an external GPS antenna in case you need to deploy in locations where there is some blockage or there's no clear sky view to obtain the GPS signal. So the optional external GPS antenna is an SMA connector, and of course the cable can go up to a maximum of 10 feet. By the way, for outdoor APs, the only default operation that is permitted is standard power. The 6 gigahertz radio will be shut off on number one if the AP is not able to get its geolocation coordinates, or if the height is not entered in the configuration page, or number two, if the outdoor AP operation is not permitted in 6 gigahertz as per the regulation in that country. So, for example, when AFC is given a go-ahead in US, so the 6 gigahertz radio, of course, is going to be on in for this 9163E. But in other countries, it's going to be, the radio is going to be completely shut off till the time the regulations permit there. So there is no need to have a GPS module for all the APs, and the APs deep inside the floor can derive its location relative to the APs with the GPS through the NDP messages that we use in RRM. If for some reason the AP cannot find an RF neighbor that has a GPS source, then it will try to derive through CDP, provided the APs happen to be connected to be the same switch. We are planning to extend the FTM or fine time measurement technique that we use in AP autolocate feature to AFC as well, to arrive at more precise location calculation of APs in a floor.
Cool. So on the 9163, so if I need to install this AP indoors, like in a freezer, for example, because I need the ruggedized form factor, I guess I could still enable 6 gigahertz thanks to that additional cable and antenna, and I could drill a hole on the wall somewhere on the roof and get that antenna, GPS antenna working. It's cool. On the map, you were showing, and you just mentioned, not all APs need to have the GPS module. What would be a standard ratio? How many APs do I need with the module versus no module?
If you want me to throw a number, I would say the ratio is like 1:5 today. But actually, we are doing a lot more tests and characterize, the number of the actual ratio that that we want to recommend the field. And as I speak, like, we're doing some tests, and please wait for some more time. And we are planning to publish some guidelines to the to the customers on the ratio that the customer should follow. Yeah,
and of course it varies per deployment.
And it varies per deployment. So, and that's the reason we want to come up with some guidelines and,
You mentioned we need to enter the height of the AP. Is this like the height based on the floor, based on the ground, or sea level?
The height that you have to enter here is based on the ground level, above the ground level. Yep.
Okay, so now we have a good understanding of AFC. You're going to show later a demo of how we turn this on the controllers and in the Meraki dashboard. What about the client devices?
Yep. So, I talked about the different device classes, the different AP types, like the low power AP, standard power AP, and etc. But if you actually look at the FCC specs, there's a lot more to it, and there are different client types that are, defined as well. Example, there's a low power indoor client that can connect only to a low power indoor AP and not to standard power AP, and vice versa. If you actually think about it from an actual deployment point of view, this is going to pose lots of challenges in terms of connectivity and roaming. You cannot roam from a low power mode to standard power mode, and and vice versa. And earlier that I mentioned, in a given floor, it can be a mix of low power APs and standard power APs, to best optimize whatever given the floor conditions. So I tried to search the FCC database and to find out the different client types that are certified by FCC. Actually, I found 0 clients as of today certified as standard power. Most of the early Wi-Fi 6E clients, when Wi-Fi 6E was launched, all got certified as a low power only client. And the most clients available in the market, especially the enterprise class today, seem to be a dual mode capable. That is, it can connect to both low power and standard power. And also, it can seamlessly roam between the low power and, standard power. From our observation, we see most low power clients, are able to connect to standard power APs today, and there don't seem to be any restrictions there. We observed, for example, Apple devices, even though they are dual client certified, it does not associate to a standard power AP as of today. If you get the latest, the iOS version and try to connect to a standard power AP, it's just not going to connect. So we are in discussion with Apple, and they're very well aware of this behavior. And the behavior will be changed in one of their upcoming releases. They are trying to time it with with the AFC availability. So once we launch the AFC availability, they're going to release an iOS image or Mac OS, which is going to change the behavior.
So there's still some things to iron out, I guess. We're still early a little bit at this. If there's a takeaway from this, it's right around the corner. We're about to have products supporting all of this, but there are a couple of gotchas to take a look at. And okay, so it's a big question, and you've alluded to when some of this is going to be available, but you have more precise dates for us as to when we can turn this on and leverage this technology.
Absolutely. So for Catalyst, the AFC will be available starting release 17.13.1, which is planned in November of this year, which is going to be any time now. We're almost the end of November. To begin with, we'll support 2 AP models, Catalyst 9136 and outdoor AP Catalyst 9163. So the support will be available in all the access points with the 1712 long-lived train, as well with the 1712 that is planned in the March of 2024. So for Meraki, released the R30, again R30, which was, I think, when went public like last in about a week back or so. That has the support for all the access points. The one thing that you need to remember that is, these releases will support, but we have mechanisms, to not enable AFC. We cannot enable AFC till the time we get the go-ahead from FCC. So once FCC gives the go-ahead, we are expecting probably it's going to be very, very early in the calendar year 2024. Then the cloud proxy services or the Meraki cloud will enable in the backend, for this AFC functionality to work. And you also mentioned about you are curious about Canada. I know you're from Canada. Canada has, of course, authorized AFC as well, and the work is in progress. And it'll be available in calendar year 2024. And we will share the timelines as we get closer. But it's definitely going to happen in 2024. And
So
the work is in full swing now. Yes.
Yeah. So I need to be a little bit more patient up here, right? Anyway. Okay. Thanks, Anand. And so I guess here we're at the end of the show, but you got a great demo for us. So take it away. Show us how easy this is on both the 9800 series platform as well as the Meraki cloud managed APs.
Absolutely. So what I want to show in the demo here's the configuration and the monitoring aspects of AFC and standard power in both the deployment stacks, the Catalyst 9800 web UI and the Meraki dashboard. So we did a couple of things. Number one, to give the best user experience, and we have made the configuration really simple and also provide enough data for monitoring. As you'll see in the demo, there are just 2 steps that is needed to enable AFC. There is no need to enter the details of the AFC providers, the credentials, the tokens, and etc., and all that's taken care in the backend. And number 2, the user experience also will be similar across both the stacks in kind of configuring. So first, we'll see the demo on the Catalyst 9800 web UI. So for the on-premises deployment, the prerequisites are, of course, the 9800 should have an internet connectivity. And the next step is, once you ensure the internet connectivity is there, the next step is you're going to plug in those the GPS module if it's an indoor AP. And if it's an outdoor AP, of course, you do not worry about because it has a built-in GPS. So with that, we'll see the demo. So first step is, as I mentioned, there are a couple of steps in configuration. So the very first step is to enter the height. Where do you do so? And the AP geolocation. And you can see, since we sorry, just replaying, I messed up. The very first step is to enter the height. As you see, since we entered the we had the GPS module, it obtained its latitude and longitude, and you can also see the source as the GNSS. All right. And once it's obtained automatically, you don't need to do anything, and you can't configure this parameter. The parameter that you're going to enter is, I'm having some hiccups. Just give me a second. You're going to enter the height. The height that you enter, of course, is in the above the ground level. And there's an example of a second AP wherein you obtain the latitude and longitude as a derived, that is not directly through a GPS, but through one of its neighboring APs. This is the very first step where you configure the height. The next step is you enable the AFC, just a knob that you enable in the RF profile, and the 6 GHz RF profile. So that's just a knob. Once you enable, what's going to happen is this controller is going to start sending out the queries to the AFC, and give a few minutes, and this APs are going to convert themselves into SPs. Not all the APs are going to go to standard power mode. The RRM plays a role here, and it'll selectively make certain APs into standard power and a low power. And we have one question that you may have in your mind is that, do you have to enter the height of each of these APs individually? Did not. You have this bulk, AP edit possibility configuration where you can go and enter the height of multiple of them. And there's absolutely no need to enter the height of each of these APs individually. And moving on to the monitoring, there are different levels of monitoring that we are providing. The very, very first level is at the controller level. It kind of gives you a health check between the controller and the AFC provider. And, there's a kind of a token mechanism, that exchange that happens, heartbeat that happens between the controller and the AFC provider like once in every hour. So this is a very, very fast step. If something is not going well, this is the page that you'll come here to see if everything is okay with the AFC provider. So once this is done, and the next level is at the individual AP level, where you can monitor the AFC status. So here's in the 360 view, you have the ability to view the geolocation of the APs. You can drill down, you have an inbuilt map, and it's going to tell you the precise location of where the APs are, present. So here's a view that it gives you the latitude, longitude, and whether the GNSS, GPS module is present, what is the source, and so on. You get a lot of details about the actual location of the AP here. And we have an AFC tab there that gives the capability if the AP is, operating in standard power, and you can see the request query that was sent to the AP, to the AFC provider, and also the response from the AFC provider. This is a nice table, that gives the different channel widths and all the channels, and what is the max ERP that is permitted for the channel. So this is the max ERP that is permitted by the AFC. It doesn't mean the AP is going to get into this ERP. The RRM plays a role here, and it determines what is the best for that floor, for that AP, and it determines the ERP for that AP. As you can see, the Uni 6 and Uni 8 is all, it's in an amber color. You won't get any response for those bands because it's not permitted to operate. And there's also a tab on the AFC statistics. A lot of data is here. It has this different charts that gives you idea about how many APs where the geolocations, and because geolocation is a very, very, it's a mandatory parameter. And if for some reason, there are some APs don't have a geolocation, it just gives a nice view, and you can go fix the geolocation for those APs, and the percentage of APs that is operating in the standard power versus the low power. And if for any reason, if an AP is, the AFC status is inactive, it just gives an, inactive status, and then you can monitor them as to see why it is inactive. For example, here is an AP that shows inactive, but if you actually look at the height is not known, the user probably forgot to enter the height here. So, of course, the controller is not going to send the query out to the AFC if any of these parameters missing. The AP has to be admin mode enabled. It has to be like you have the geolocation and needs to be known, and the height has to be entered. All these parameters have to be there for the controller to initiate the AFC query. So there's a lot of details. This is going to help the customers to, if you want to troubleshoot anything. This page is, contains very detailed information. Here is the view about the Meraki. Very, very similar steps. The very first step is where you go and enable the RF profile for the 6 gigahertz. There's just a knob that that you enable for AFC, the standard power service. What's going to happen at this step is, if this is a very fast time that you're enabling, it's just going to pop up a window saying that here you need to configure the heights, and then it's going to take to a page where you can bulk edit all the heights of the the AP. But here this is a production system, so that the pop-up is not seen there. But if you're enabling for the first time in Meraki dashboard, it's moment you enable AFC, it's just going to prompt you to enter the height. And for some reason, you add a new AP and you want to enter a height, you can go to that access point page, and you can enter the height manually though. So if you want to change the height, if you change the location of the AP, and if you want to change the height, you can do so here. And there's also an AFC tab. It has a very detailed status as to what the current the AFC status, whether it's active, and what is the current power board, if it's operating in a standard power or low power. And it also has a nice geolocation view. It has the map, and it just tells you the location, the uncertainty factor, and so on. And similarly, it also has this the nice view of the channel and the power levels. It's of course the color is slightly different. Between Meraki and Catalyst. But the user experience same. You kind of get all the information in both the deployment modes.
Awesome. Awesome demo, and it certainly does seem to be very easy to just turn it on. And don't have to deal with the AFC systems providers and whatnot. You referenced on both platform. You reference a bulk edit for the entering the height. On the 9800, this you're actually referring to this new bulk functionality that we introduced in 1712, right?
Yes, that's correct.
Yeah,
that's correct.
Certainly helps out, doing these types of actions on the controller. Okay, so we're at the end of the show. I think Anand, you did an awesome job giving us an update and explaining all of what's happening around the AFC. So back to you, Dan. Any remaining questions online or that we'd like to answer here at this point, or any close it?
Yeah, thanks, Francis. Thanks, Anand. There is one question. It just looks like it just came in here. Why would I need to use the GPS modules with indoor APs? What does this enable for an indoor deployment?
So it's per the rules, the regulations. The regulation mandates that the geolocation coordinates cannot be has to be obtained in an automated way, and it cannot be manually entered. And that's the reason that we need to use a GPS module even for the indoor APs. I mean, otherwise it's just okay. The users can probably fool around. I could be in California, but I can just enter some Texas. Sure. And fool the system, so they want to avoid. So that's the reason.
And maybe portion of that question was, why would I want standard power? You explained it earlier in the session there. Why would I want standard power indoors? It's an option. It's, maybe you do need a little bit more power to get, in areas of the building, and instead of deploying additional APs just for 6 gigahertz, maybe standard power will fix it. But as you just mentioned, Anand, you do need the precise coordinates from a GPS module.
Absolutely.
Anything else there then?
No, looks like we're good on questions.
All right.
I did want to just take a moment to apologize. We did have some technical issues at the start of the broadcast, so we are going to go back and fix that before we upload this to YouTube. So just wanted to apologize and let everyone know that. And then also, I did want to thank Anand and Francis. Great info, great session on 6 gigahertz and AFC. I love the demo and all the information. So we'd love to have you back, Anand, in the future to talk Wi-Fi 7. That sounds good.
Thank you. Sure. Next year is all going to be about Wi-Fi 7 and a lot of exciting stuff that's happening, and development is in full swing, and we'll sure connect in another few months from now, and we'll talk about Wi-Fi 7.
Great. All right, so just a couple reminders here before you close out. If you will get a survey at the end, if you could please complete that survey. We love to get your feedback to continue to make these sessions and episodes better. And also a quick reminder, you can find us on YouTube, youtube.com/@getunplugged, or you can register for upcoming episodes at cs.co/getunplugged. And if you want to get a hold of us, you can contact your local account team, your Cisco account team, with any questions, or you can always email us directly at getunplugged@cisco.com. Until next time, stay connected and unplugged.